So we got the expression for two velocities after collision, v1 and v2, and we are going to discuss the special cases. So when masses of the two bodies are equal, that means you think about the two bodies. Both the masses are equal to, for example, while playing the carom board, you can see both the coins are having almost the same mass. So such a collision you can, and they are moving in the same direction, the same straight line it is moving. Or you can consider two balls after same type of ball, same mass, they collide and move along the same straight line. Such a collision you have to think m1 equal to m2. Both the masses are equal. Then what will be the velocity v1? So when we substitute in the equation, we get v1's equation, you can see. m1 equal to m2. Consider, so this will be what? m1 equal to m2, 0. So this term will not be there. Then what about this term? m1 to m, m1 equal to m2 equal to m. So you can write 2m. 2m u2 by 2m, but 2m cancel, and we get u2. So v1 equal to u2. What's the meaning? v1 equal to u2. We can go to the figure. v1 equal to u2. v1, you see, this is v1 after collision velocity. v1 equal to u2. That means first body's velocity becomes second body's initial velocity. So when two bodies are of equal mass, and if they collide, what happens? First body gets second body's velocity, v1 after collision. First body get second body's velocity. Understand? So that is when two bodies of equal mass, that is happening. That is the special case. Okay? So v1 is equal to u2. That is velocity of A after collision is velocity of B before collision. Exchange their velocity. Similarly, v2 is equal to u1. Velocity of B after collision is equal to velocity of A before collision. Hence, two bodies of equal masses undergo elastic collision in one dimension. Their velocities are just exchanged. Understood? So when two bodies are having equal mass, what happened? Initially they were going with the velocity, different velocity, u1, u2. After collision, what happened? They exchanges their velocity. Understood? Next case we can see. Then explanation is there. This result has an important application in a nuclear reactor. Fast-moving neutrons in a nuclear reactor are slowed down by making them collide against the nuclei of a moderator. Moderator means it is heavy hydrogen, like that. Hydrogenic atoms like protons. Understand? So what is happening in a reactor? What is the fuel used in a reactor? Uranium. Uranium-235, mass number 235. That is the fuel used. When that uranium is bombarded with a slow-moving neutron. Uranium is bombarded with a slow-moving neutron. And what happened? Then only the fission reaction takes place. And see, slow-moving neutrons are needed. So what is done is, the speed of neutron is reduced by passing through this heavy, that means heavy water. That means heavy water. That is the moderators. Paraffin, heavy water, paraffin. They are the moderators. They are hydrogenic materials. So they are actually this neutron's mass, almost neutron's mass. This one. Understand? So when it is passed through heavy water, when fast-moving neutron is passed through heavy water, what happens? Both are same mass. Heavy water is almost at rest. So neutron exchange its velocity. Fast moving neutron is slowed down. Heavy water is almost at rest. So fast moving neutron's velocity is reduced. Understand? So that principle is applied here. So if the two bodies are of almost equal mass, after an elastic collision in one dimension, they exchanges their velocity. That principle is utilized here to slow down fast moving neutron. Understand? And that process is known as moderator, that means slowing down the fast moving neutron passing through heavy hydrogen or heavy water or paraffin, etc. So these are moderators. Heavy water, paraffin, etc. are moderators. What is the purpose in a reactor? Slow down fast moving neutron. Why we slow down? Only slow moving neutron can produce fission reaction. That's why. In a nuclear reactor, which reaction is taking place? Nuclear fission. What is fission reaction? When a heavy nucleus of uranium is bombarded with a slow-moving neutron, large amount of energy is created. That is fission reaction. So that you will study later in detail. Now we want to know this fact. That means how the fast-moving neutrons are slowed down by passing through these moderators. They exchanges their velocity. That is used here. That principle is used. Okay. Then, when the target body B is initially at rest, next case, the second body B is at rest. That is U2 equal to 0. So that second body is at rest. U2 equal to 0. Second body's initial velocity 0. That a carom board example you can take. When we strike a coin, so it hit on a body at rest. That means other coin at rest, isn't it? When we strike it, actually it is at rest. When we strike almost same mass body we are striking. So when the target body B is initially at rest, that is U2 equal to 0. So what is V1? We can see V1. Substituting in the equation for equation 6, we get V1. U2, second term will not be there. So the first term only will be there. M1 minus M2 into U1 by M1 plus M2. So what we get? M1 minus M2 into U1 by M1 plus M2. Similarly, V2, we can see V2. Show you that. V2, you see. Second body at rest. Says that second body is at rest initially. So, U2 equal to 0. This term 0. This term becomes 0. Then what remains? Only this term. 2M1 U1 by M1 plus M2. That term only remains. That case is what we are discussing now. Okay. So V2 equal to 2M1 U1 by M1 plus M2. And in these two equations, so what is the case? You all have to know what's the case now. The target body B is initially at rest. Target body B is initially at rest. Then what is the velocity V1? What is the velocity of the body V2? That case is what we have discussed now. Then again some special cases. You can see. 3 cases arise further in those two equations. When masses of two bodies are equal, that is M1 equal to M2, what is V1? Again, we have to go to the equation. What is the case? M1 equal to M2. Okay. Let us substitute M1 equal to M2. See, in this equation, M1 equal to M2, what happened? M1 minus M2, that term will be 0. So V1 equal to 0. First body V1. What is the V1? After collision, velocity of body A. That becomes 0. Understand? So when what is the case now? You have to imagine that to carrom board. Just think that carrom board while playing carrom board. That B body is at rest. We strike the coin A. Coin A move and hit the body B. They are of equal masses. What happens? The A body which we strike, that gives its velocity to B. B is already at rest. But when we strike the coin A, that coin hits the coil B and its velocity is exchanged. That happens when two bodies are of equal mass and B is initially at rest. That is happening. Understand? So that case is what we have discussed here. V1, first body's velocity becomes 0. At the same time, second body get the first body's velocity. V1, A means when the coin which we strike, its velocity becomes 0 after hitting the other coin. When it happens, when they are of equal mass. Understand? So V1 and first body's velocity becomes 0. The coin which we strike, that will get velocity first of the body B. Body B is at rest. So when we strike the coin A, it hit on coin B and exchanges their velocity. So B's velocity is already 0. That velocity is given to A. Understand? So velocity of A becomes 0, but velocity of B get the other body's velocity. So with the 2m1 u1 by 2m1, that is u1. Children, if you have doubt, you can call me. Then that is body A comes to rest and body B starts moving with the initial velocity of A. You can consider the example of playing carrom board. That will be a good example because they are almost the same mass. The coins are having almost same mass. When next special case, when body B at rest is very heavy. Very heavy. For example, when a coin strike or when a ball strike on a wall, body B at rest is very heavy. When we throw a ball to a wall is very heavy. Wall is very heavy. And when we hit it, or when you throw a ball to the wall, what happens? When we throw a ball towards a wall, it rebounds. Rebounds. That is happening. That case is what we are discussing here. When body B at rest is very heavy, M2 is very much greater than M1. That is, M1 can be ignored. That ball mass can be ignored compared to the wall mass. Wall is very heavy. So, hence when a light body A collide against a heavy body B at rest, what happened? A rebounds with its own velocity and B continues to be at rest. We know that when we throw a ball rebounds, but the wall continues to be at rest. That is happening. So when body B is very heavy, what happened? Body A hit and rebound. And body B continues to be at rest. These are all special cases. This is what happens when a ball rebounds to the same height from which it was thrown on a striking floor. That is the case when we strike the ball on the floor. Ball rebounds. Floor remains there itself. No velocity to the floor. Very heavy. Nothing happens. Next, please. When body B at rest has negligible mass, other case. Body B at rest has negligible mass, and that is M2 can be ignored compared to M1. Then what is the velocity? So body B at rest is the hitting, for example, a bus and an auto rickshaw, like that you can consider. Body B at rest, a auto rickshaw is at rest. Body B at rest. And a negligible mass compared to bus mass. Okay, auto rickshaw and bus. Bus is very heavy, and the auto rickshaw is lighter compared to the bus. Okay, in that collision, what happened? Putting m2 equal to 0. M2 we have ignored. Auto rickshaws mass we have ignored, very small mass. And what is V1? In the expression we can see V1. Can go to the equation for V1. See, M2's mass is ignored. Auto rickshaw mass is ignored. So what we get? M1, but here it will be M1. From M1 and M1 cancel, we get U1. U1 we are getting. V1 equal to U1. Then V2 equal to 2M1 U1 by M1 plus M2. So what M2 we can ignore. M2, 2M1 by M1. What is it? M1 cancel, 2U1. So V2, that means auto rickshaw. Auto rickshaw's velocity becomes double the velocity. Double the velocity. That is happening. Today. V1 equal to U1, V2 equal to 2U1, double the velocity. Hence, when body A collides against a light body, body A on a bus collides against a light body on a auto rickshaw. Okay, at rest, auto rickshaw is at rest. The body A keeps on moving with the same velocity. Body A keeps on moving with the same velocity. No change to its velocity. Of its own, and the body B starts moving double the initial velocity of A. Double the initial velocity of A. And auto rickshaw moves with double the velocity of the bus എന്നാണ് പറയുന്നത്. അത്രയും സ്പീഡിൽ അതാണ് വലിയൊരു ബോഡി വന്ന് ഹിറ്റ് ചെയ്ത് കഴിഞ്ഞാൽ ചെറിയ ബോഡിക്ക് ഉണ്ടാകുന്ന വെലോസിറ്റിയുടെ കാര്യമാണ് ഈ പറയുന്നത്. കൊളിഷൻ കഴിഞ്ഞാൽ ഡബിൾ ദ വെലോസിറ്റി ഓഫ് ദ ബസ് ആയിരിക്കും കിട്ടുക. അത്രയ്ക്കും ഭയങ്കര വെലോസിറ്റിയിലായിരിക്കും തെറിച്ചു പോകുക. But these are the special cases to discuss. All of you go deeper into that and understand the meaning. Let's substitute in the equation. You will get the answer. The next is elastic collision in one dimension. Inelastic collision. Elastic collision is what we have discussed and the special cases. That derivation I told you, very important. Derivation study well. Special cases also you have to study for problem doing and all. Then next is inelastic collision. I have discussed that. What is inelastic collision? Can anyone tell inelastic collision? Inelastic collision will tell. In that collision which is not conserved. Which is not conserved in that collision. Anyone tell, please?
Teacher, kinetic energy is not conserved.
Very good. Who is that? Dibaksha? Very good. So, kinetic energy is not conserved. Momentum conserved, total energy conserved, but kinetic energy is not conserved. Such a collision is known as inelastic collision, and in one dimension means after collision also they move along the same straight line, not deviating from the direction. After collision also they move along the same straight line. That is one dimension collision. So before collision I have shown the figure here. Mass, body mass m1. Consider if that body is having mass m1 and a small body, another body of mass m2, different masses. And you see u2, initially u2 is 0. That case is what we are discussing here. Body at rest. And this body, for example, a wooden block, and this can be considered as an arrow which come and hit on this one. An arrow hit on this one, like that case. Second case, the body is at rest and both move together. Both after hitting the wooden plank, both move together with a velocity, common velocity. Both move together with a common velocity. So before collision, what are their velocities? m1 is the mass of the body, first body, and its velocity u1. It hit on a body at rest. For example, a wooden block. This is a narrow arrow moving with a velocity u1. And it hit, and what happened? Our kinetic energy is completely lost for this. And it is not completely lost here, but they move together. Okay. The figure shows perfectly inelastic collision between two bodies of masses m1 and m2. Body of mass m2 m2, what happened? It moves with a common velocity, another velocity. Initially at rest, body is initially at rest. Okay, we refer to this body as the target. So the body which is at is referred to as target. The incoming body of mass m1 moving with initial velocity u1 is referred to as projectile. Arrow we can consider as a projectile. Other body, wooden block, that we can consider as target. So the projectile hit the target. After collision, the two bodies move together with a common velocity v. Their velocity is changed to v. The collision is perfectly inelastic. As the total linear momentum of the system cannot change, momentum is conserved. We know in elastic collision also momentum is conserved. So initial momentum will be equal to final momentum. So what is the momentum before collision? m1 u1 plus m2 u2. That's equal to final momentum. What is the final momentum? Both the bodies move together with a velocity v, m1 plus m2 into v. So from that, u2 is 0. We have already told wooden block is at rest, arrow is hitting on it. So its velocity is 0. u2's velocity is 0. So this term becomes 0. So m1 u1 is equal to m1 plus m2 into v. Understood? So therefore, v, common velocity, we can calculate common velocity that v equal to m1 u1 by m1 plus m2. Question number 1. Knowing m1, m2 and u1, we can calculate the final velocity v as the mass ratio m1 by m1 plus m2 is less than 1. We all know m1 plus m2 will always be greater than m1. So this term m1 by a big quantity, m1 by a big quantity is the denominator. So we get a less than 1 answer. That means 1 by 6, suppose 1 by 6. 1 by 2 itself, it is 0.5. 1 by 2 itself, it is 0.5. Like that. So this term will be less than 1. m1 by m1 plus m2 is less than 1. Therefore, v is always less than u1. This will be v less than u1, because 0.5 into any velocity, that also becomes less. So v is always less than u1. V means what? Common velocity. Velocity, so velocity is decreased. After collision, velocity is decreased. That is, kinetic energy is lost. So it is an inelastic collision. V, after collision, they move with a lesser velocity than the initial velocity of the body A. So what happened? Kinetic energy is lost in that. So that is an inelastic collision. We can calculate loss of kinetic energy. So what we have to find out? What is the initial kinetic energy? What is the final kinetic energy? And you have to find the difference. That will give the loss in kinetic energy. You see, total kinetic energy before collision E1 half m1 u1 square. Second term will be 0 because second body is initially at rest, u2 equal to 0. So that will not be there. Second term will not be there. E1 equal to half m1 u1 square. Total kinetic energy after collision. After collision, they move with a common velocity v. So half into m1 plus m2 into v square. That is the total kinetic energy after collision. Then you are substituting for capital V, or just we already found the formula for V, that is substituted here. m1 plus m2 into m1 u1 by m1 plus m2 whole square. Then one term m1 plus m2 will cancel. and only here it is square. So one term remains here. E2 equal to m1 square u1 square by 2. 1 m1 plus m2 cancel. So 2 into m1 plus m2. Then loss we calculate. Loss in kinetic energy. E1 minus E2. E1 is half m1 u1 square minus E2 is this one. M1 square u1 square by 2 into m1 plus m2. Then we take the LCM. 2 into m1 plus m2 is LCM. Half is there in both the terms. So 2 is written in the denominator and m1 plus m2 is taken as the LCM. And what happens? m1 u1 square into m1 plus m2 minus m1 u1 square. This is taken as the LCM. Then you expand this. m1 into m1 u1 square. m1 square u1 square. Second term, m1 m2 into u1 square. Okay. Minus m1 square u1 square. That also written. Then this term cancel. What remains? m1 m2 u1 square by 2 into m1 plus m2, which is positive. Therefore, why it is positive? Because we are squaring. This is product. This is sum. So always this will be greater. And this is u1 square. So this quantity altogether becomes a positive quantity. Therefore, some kinetic energy is lost in inelastic collision. We are proving some kinetic energy is lost in inelastic collision. So that is inelastic collision in one dimension. So what is inelastic collision? Kinetic energy is lost. And what we are proving? There is a loss in kinetic energy.